When we talk about rubies, what's the very first image that comes to your mind? Maybe a luxury piece of jewelry on display, or a perfectly cut stone set in a $1 million ring. But here's the truth. Very different from what most people believe. These stunning gemstones once looked nothing like that. In their natural state, rubies are rough, imperfect, and far from glamorous. And yet, once they're cut and polished, they can reach astronomical values. But where do these rubies actually come from? And more importantly, could you find a ruby hidden among the pebbles of a river? Is it really possible that one of the most valuable gemstones on Earth could be lying out there in nature, within reach of anyone who knows what to look for? The answer is yes. And it's not just a distant theory. Ordinary people have already found rubies in trails, streams, and river gravels across the United States. Stories like these happen every single year, proving that the opportunity is real, but only for those who learn to read the signs that geology leaves behind. Now imagine this. You're walking along a river near your town, one you've probably seen hundreds of times, when suddenly a small red pebble catches your eye. At first glance, it could be anything, even just a piece of glass. But what if I told you that tiny fragment could actually be a natural ruby, uncut and raw, with a value that could surpass the price of a luxury watch? Once polished, of course. Sounds hard to believe, right? But the reality is that many of the world's most valuable gems, including $1 million diamonds, were discovered in nature by regular people searching through rivers for hidden treasures. And yes, this has happened right here in the United States. In other words, rubies aren't limited to exotic mines on the other side of the world, in places like Myanmar or Mozambique. They can also be found in alluvial gravels much closer to home. And that's why in this video, we're going to reveal exactly how you can find rubies in any river near you. As a bonus, you'll also discover how much a river ruby can be worth, and what signs separate an ordinary stone from a gem that could change your life. And if you still have doubts, consider this striking fact. In some regions, the odds of finding a natural ruby in a river are many times higher than winning the lottery. While millions of people spend money on tickets with almost no chance of return, quiet rivers in states like North Carolina, Montana, and even Alabama hold gems worth thousands of dollars per carat. So pay close attention, because you're about to watch exclusive content that could forever change the way you look at every river in your area. To understand how a ruby can show up in a simple riverbed, we first need to go back millions of years, deep into the earth where it all began. A ruby is nothing more than a variety of the mineral corundum with the chemical formula aluminum oxide. What sets it apart from sapphire, which is also corundum, are the trace elements present in its crystal structure. In rubies, it's the presence of chromium that produces their signature red color, ranging from softer tones to the famous pigeon blood, that vivid, intense red that commands the highest prices in the gem market. This formation process happens in environments of high pressure and temperature, usually within metamorphic rocks such as marble, gneiss, and schist. In those conditions, the right chemical mix and very specific geological factors allow corundum crystals to form. But here's the key point. Most of the corundum produced in nature isn't gem quality. Many crystals are dull, opaque, or full of inclusions. Only a very small fraction develops the clarity and color necessary to be considered high-value rubies. So if rubies are born inside solid rock, how do they end up in ordinary rivers, often far away from their original host? The answer lies in the combined action of erosion, weathering, and river transport. Over thousands or even millions of years, rainwater, temperature changes, and natural physical and chemical processes break down the rocks that once held the crystals. On a hillside or mountain, it only takes a crack or a landslide for pieces of metamorphic rock to break free, releasing small rubies into the environment. Once freed, these crystals are carried by gravity and by water. Flash floods, landslides, and the steady current of rivers transport rubies for long distances. And here's the critical detail. Ruby, like all varieties of corundum, has a hardness of 9 on the Mohs scale and is extremely resistant to wear. While softer minerals break apart and disintegrate during transport, rubies remain intact. That's why they can be found in river gravels even after traveling miles from their source. But it's not just their toughness that ensures rubies survive. Their relatively high density makes them behave differently in a river's flow. Unlike lighter minerals that keep getting carried downstream, rubies tend to settle in very specific spots where the current slows down. These places are known as trap points or natural concentration zones. In practice, this means that rivers act as natural gem concentrating machines. Over time, lighter particles get washed away, while heavier minerals like garnet, magnetite, gold, and rubies get deposited in select pockets. That's why experienced gem hunters know exactly where to look: along the inner bends of rivers, behind large boulders, in calm eddies, or at the bottoms of natural potholes. In those spots, slower-moving water creates natural traps where valuable minerals accumulate. This natural process turns almost any river into a potential open-air treasure site. A ruby may have formed in a mountain at dozens of miles away, but the combination of erosion, transport, and deposition eventually delivers it to places that are accessible to anyone paying close enough attention. The rivers don't just move rubies. They sort and concentrate them, leaving them in plain sight for those who know how to read the geological signs. That's why so many rubies have already been discovered in rivers that, at first glance, look completely ordinary in the United States. Knowing that rubies can be found in rivers is already a big step, but to really increase your chances of finding them, you need to understand the clues that nature leaves behind. Rubies don't appear alone in isolation. They are usually associated with certain types of rocks and with a group of minerals that form under the same conditions of pressure, temperature, and chemistry. That's why when we talk about geological indicators, we're referring to these markers. Minerals that may not be valuable on their own, but serve as signs pointing to environments where rubies are likely to occur. This method is critical because rubies are rare. If you only search by trying to spot the red shine of a crystal, you could spend years without finding anything. But if you learn how to identify the right host rocks and companion minerals, you'll direct your search to the places with the highest probability of revealing a gemstone. It's like following a trail of evidence. Every associated mineral you find in river gravel suggests that the geological environment matches the one where rubies form. Let's look at the main allies of any ruby hunter: mica, feldspar, garnet, and magnetite. Mica is perhaps the easiest indicator to recognize in the field. It has a metallic-like shimmer and splits into thin sheets, almost like the pages of a book. It's commonly found in metamorphic rocks such as schist and gneiss, which are also classic environments for corundum formation. When you see mica flakes glinting among the river stones, it's a strong sign that the area went through intense metamorphism, the same process that can produce rubies. Mica is also often associated with aluminum-rich zones, and aluminum is the key element in corundum. Feldspar is another important indicator. It appears in different colors: white, pink, or gray, and is recognizable by its flat surfaces and subtle reflections. Like mica, feldspar is common in both metamorphic and igneous rocks that, under the right conditions, may also host rubies. Its presence signals that you're in an aluminum and silica-rich environment where corundum could have crystallized. Feldspar itself isn't a valuable gem, but it works as a warning that you're close to the right setting. Garnet deserves special attention because it often shows up right alongside rubies in river deposits. It can be red, orange, or even brown, and usually appears as rounded, durable crystals that survive transport in rivers. In the field, an inexperienced prospector might easily mistake garnet for ruby. Since both share a deep red color, the difference is that garnets are usually less transparent and have a softer, glassy luster. The key point is this: if you find abundant garnets in river gravel, there's a good chance rubies could also be nearby, since both form under similar metamorphic conditions. Finally, there's magnetite, a black, metallic-looking iron oxide. Its most distinctive feature is its strong magnetism, which makes it easy to identify with a simple magnet. Magnetite isn't directly tied to ruby formation, but it frequently appears in alluvial deposits that concentrate heavy minerals. In other words, where there's magnetite piling up in a river, the conditions are favorable for other dense minerals too, like gold, garnet, and of course, corundum. Finding large amounts of magnetite means you're standing in exactly the type of natural trap where the current has separated lighter minerals from heavier ones. And rubies belong in that group. Together, these four indicators, mica, feldspar, garnet, and magnetite, act like an invisible map guiding gem hunters. Every time one of them appears, it's a signal that you could be close to the ideal setting for finding rubies. And here's the real advantage. While rubies themselves are rare and easy to miss, these indicator minerals are far more common and much easier to spot. Now that you know how rubies form and which indicator minerals can help you find them, it's time for the most practical step: where exactly to search inside a river. This is where many beginners go wrong. They search randomly, spend hours panning in the wrong spots, and eventually convince themselves that rubies are impossible to find. The truth is that rivers follow very clear physical rules, and once you understand those rules, any stretch of gravel can become a real treasure map. The first key concept is what geologists and prospectors call trap points, natural concentration zones. A river acts like a giant sieve. It carries lighter sediments downstream, but heavy minerals like garnet, magnetite, gold, and corundum, the family that includes rubies, settle in places where the current slows down. The main strategic points are inside bends of the river. When water curves, the current is faster on the outside and slower on the inside. It's in that slower inner bend that heavy minerals settle. If you look closely, you'll notice the gravel there is darker and denser, a sign that rubies could be concentrated in that spot. Behind large rocks or logs, obstacles in the riverbed create small zones of turbulence and calm water immediately behind them. Those eddies act like filters, making heavier minerals drop and stay trapped. Panning just behind big boulders often means working with material that nature has already pre-sorted, bottoms of natural potholes. In deeper stretches, especially where the river scours small pockets in bedrock, the swirling water creates natural traps for dense minerals. These pockets can act like safes, holding gems for centuries until someone finally uncovers them. Recognizing these points takes practice, but it mostly comes down to watching the details in the gravel. Often what separates an ordinary spot from a productive one is the color and texture of the material. Lighter, sandy gravels usually indicate lighter minerals. Darker zones with shiny, dense fragments point to concentrations of heavy minerals. That darker gravel could include garnet, magnetite, ilmenite, and with luck, small ruby crystals. Another essential factor is knowing the difference between active alluvial deposits and ancient deposits. Active deposits are in the river's present-day flow, where water is still moving minerals around. They change after every flood, constantly reworking gravels and creating fresh concentrations of heavy material. The advantage is that new crystals are always being released upstream. The downside is that you'll spend more time separating what's really worth keeping. Ancient deposits, on the other hand, sit in areas known as river terraces. These are higher gravel beds that once were part of the active river, but are now dry or set back from the main channel. Terraces can be even richer than the modern riverbed because they represent thousands of years of accumulation. In fact, many historic ruby and sapphire finds in North Carolina came from old terrace gravels that people had overlooked. To tell them apart, check the position of the gravel. If it's right at the water's edge, wet and constantly rearranged, it's an active deposit. If you find compact, layered gravel above the waterline, you're probably standing on a terrace. Both can hold rubies, but each requires a different collection strategy. And perhaps the most important detail of all, pay attention to subtle changes in the gravel. Even a slight increase in darker, heavier minerals is enough to indicate a promising spot. That happens because density naturally sorts the material. Lighter quartz and sand wash further downstream, while heavier minerals stay caught in small pockets. Training your eye to notice these shifts in color and texture is what separates an amateur from someone capable of spotting high-potential deposits. So far, we've talked about how rubies form, how they end up in rivers, and the indicator minerals that help identify them. But here's an essential point. When you actually come across a rough ruby, it won't look anything like the brilliant gemstone you see in a jewelry store. On the contrary, natural rubies in their raw state are usually opaque, irregular with worn edges, and often covered with crusts of other minerals. They don't shine with that vivid red we associate with cut stones. Sometimes they look like nothing more than ordinary pebbles mixed in with the gravel. That's why so many people have walked right past a ruby without realizing it. To tell the difference, you need to observe carefully. A quality rough ruby will show a red color that persists even in the shade, unlike glass or reddish quartz, which only sparkle under direct sunlight. In addition, because of its high hardness, 9 on the Mohs scale, ruby easily scratches glass and doesn't wear down with superficial marks. This simple test already separates a gemstone from a common stone. Now, how can you find these rubies in rivers in practice? The traditional technique used by prospectors is manual panning. You can start with a gold pan or a metal sieve, always focusing on strategic spots like inner bends, potholes, or behind large boulders. The process is simple. Collect gravel, wash it in the pan, and let the water current carry away the lighter material. What remains at the bottom are the heavy minerals, where rubies, sapphires, garnets, and magnetite may be found. Another important tool is a hand lens. Many times rubies appear in very small sizes, just a few millimeters, and to the naked eye they can be mistaken for quartz or garnet fragments. With a 10x loupe, you can better see the internal color, translucency, and even the fractures typical of corundum. This practice greatly increases your chances of spotting a real gemstone. Now let's talk about the places in the United States where this type of prospecting has already produced results. Perhaps the most famous destination for anyone dreaming of finding rubies is the state of North Carolina, especially the Franklin and Cowie Valley region. There, alluvial deposits concentrate rubies and sapphires side by side, carried over centuries by river currents. What makes the region even more interesting is its local tradition. Many mining sites allow visitors to practice panning, and quality rubies are still being found today. Another important location is Montana, world-renowned for its sapphire deposits, but also home to ruby occurrences. These crystals were carried by glacial rivers that crossed ancient metamorphic formations rich in corundum. In places like the Missouri River and Rock Creek, prospectors have reported finding small sapphires and rubies in dark gravels. The landscape is completely different from North Carolina, but the natural concentration process in rivers follows the same logic. Less famous, but equally relevant, is Alabama, where alluvial deposits contain rubies and sapphires mixed in the gravels. There, the geological environment favored the formation of corundum in different shades, and rivers carried these crystals into accessible alluvials. Although the specimens are generally smaller, there are reports of finds that catch the attention of collectors and jewelers. And what's most fascinating is realizing that this pattern isn't exclusive to the southern United States. In Yukon and Baffin Island, in Canada, similar glacial processes transported rubies and sapphires long distances, depositing them in icy rivers and gravel beds. This continental connection shows how the same type of geological setting can create ruby occurrences in completely different environments, from subtropical valleys to Arctic rivers. What all these regions have in common is the combination of 3 factors: metamorphic rocks rich in aluminum, intense erosion capable of releasing the crystals, and rivers that act as natural concentration machines. For gem hunters, knowing these patterns means turning the search into a logical and focused process instead of relying only on luck. Finding a red stone in a river is only the beginning. The most delicate step comes next, figuring out whether it's truly a ruby or just a look-alike mineral. Many people have mistaken quartz, garnet, or even glass fragments for rubies. The difference lies in the details, and that's where a few simple tests come in, tests that any prospector can perform right there in the field. The first is the hardness test. Ruby belongs to the corundum group with a hardness of 9 on the Mohs scale, just below diamond. This means ruby easily scratches glass and quartz, but is not scratched by them. Quartz with hardness 7 may look similar at first glance, but can't cut glass in the same way. Garnet with hardness between 6.5 and 7.5, also falls short of corundum's toughness. A quick, careful test is often enough to spot the difference. The second is the weight test. Because rubies have higher density, they feel heavier in the hand than quartz or garnet of the same size. This difference can seem subtle at first, but with practice, it becomes easy to notice. Many gem hunters use this tactile sense as a first filter to separate common stones from potential gems. A third tool is ultraviolet light. your UV. In many cases, high-quality rubies show a red-orange fluorescence under long-wave UV light. This effect is caused by chromium atoms within the crystal structure and doesn't usually appear in the same way in other red minerals. Not all rubies fluoresce, but when they do, it can serve as another useful clue in identification. Now, if you confirm the crystal really is a ruby, the big question arises, how much is it worth? The answer isn't simple because the value of a ruby depends on multiple factors: color, clarity, size, origin, and the quality of its cut. Raw rubies found in rivers usually sell for less than cut stones, but they can still surprise you. A small crystal of 2 to 3 carats with strong color and decent translucency might already attract collectors and cutters willing to pay a few $100s. If that same ruby is skillfully cut and shows uniform color, its price can easily climb to thousands of dollars per carat. The most important point is the relationship between size and quality. On the market, small rubies of exceptional quality are often valued more than large rubies with poor color or heavy inclusions. To illustrate, 2 rubies of 20 carats each with saturated color and excellent transparency could fetch a total value much higher than a single 40-carat ruby with low clarity. On the other hand, a 40-carat ruby of high quality is an extreme rarity and would command an astronomical price. Another detail to keep in mind is that alluvial rubies, the ones found in rivers, usually have rounded shapes due to water transport. This can reduce the amount of material available for cutting, but it also signals toughness and durability, traits that lapidaries appreciate. In the international market, rubies of exceptional quality can reach prices of tens of thousands of dollars per carat, especially those with the famed pigeon blood color, that vivid, intense red. Medium-quality rubies, even in modest sizes, still range from a few hundred to several $1,000s. It all comes down to the combination of color, clarity, and craftsmanship. That's why when you find a ruby in a river, it's wise not to think only about size. Instead, focus on the overall quality of the crystal. A small stone with vivid appearance can be a far greater treasure than a large, dull block. Now imagine that after watching this video, you finally find a small red pebble in the river gravel. It looks a lot like the rough rubies we've shown here. You test it against glass, you notice the color holds even in the shade, and everything seems to indicate it could be a ruby. But then the question arises, what if it isn't? How can you be absolutely sure? This is a common dilemma for beginner prospectors. There are several stones that can look like rubies in their raw state. Red garnets are one of the most frequent examples. There's also spinel, which for centuries was mistaken for ruby, even in royal jewelry. Fragments of reddish quartz, and sometimes even natural glass, can be just as deceptive. The truth is, in nature, confusing these stones is normal. It happens even to experts. But here's the key detail. Just because a stone isn't ruby doesn't mean it's worthless. High-quality spinels can sell for thousands of dollars. Well-formed garnets are widely used in jewelry around the world. Even certain colored quartz specimens can be of interest to collectors. In other words, you should never discard a stone simply because it isn't what you first thought. Identification always comes before any decision, and this is where the danger lies. Many people find a promising stone and, without knowing what they really have, sell it for next to nothing to opportunistic buyers. It's common to hear stories of someone trading away a rare gem for just a few dollars, after being told, "That's worthless, it's just quartz." The result? Huge losses and lifelong regret. To avoid this kind of mistake, you need practical and reliable information. And that's exactly why we created the channel's book, Gemology Journey for Beginners. It was designed as a field guide for anyone who finds stones and doesn't want to rely only on someone else's opinion. Inside, you'll learn how to tell rubies apart from garnets, spinels, and quartz using simple tests and direct observations. It's a step-by-step manual that turns curiosity into confidence and protects you from falling into costly market traps. And this is just the beginning, because even once you can tell a ruby from quartz, there's still a bigger challenge ahead, distinguishing a true ruby from a high-quality spinel, a gem that can fool even professional jewelers. And that will be the topic of our next video. We'll show you exactly how to analyze the technical details that separate these two gemstones. and why even the British crown has been fooled by this similarity. Thanks for liking and subscribing. Good luck, gem hunter.